Welcome to my 10th tutoring session in A-level chemistry. In this video, I'll talk about effective nuclear charge and shielding effect in group 2 elements. What is shielding? Shielding refers to the phenomenon where core electrons partially block the attraction between the positively charged nucleus and the outer electrons in an atom. In this atom, we find totally 4 shells. The first shell with core electrons acts as shield 1. The second shell with core electrons acts as shield 2. And the third shell with core electrons act as shield 3. Now these 3 shells containing the core electrons act as respective shields, and thereby they partially block or reduce the electrostatic force of attraction between the positively charged protons present in the nucleus and the electrons present in the outermost valence shell. I have color coded the core electrons in red and valence electrons in blue, and the double-headed arrow refers to the electrostatic force of attraction between the positively charged protons present in the nucleus of the atom and the valence electrons present in the outermost shell of the respective atom. What is effective nuclear charge? Effective nuclear charge is the electrostatic attraction between the nuclear protons and the electrons present in the outermost shell. That is, I'm referring to the valence electrons. In this atom, we find the positively charged protons present in the nucleus and 2 valence electrons present in the outermost shell of the atom. And what is Zeff? Zeff is the abbreviation for effective nuclear charge, and it refers to the electrostatic force of attraction between the positively charged protons present in the nucleus and the valence electrons present in the outermost shell. Now let me explain the shielding effect and effective nuclear charge in group 2 elements like beryllium, magnesium and calcium. The core electrons are highlighted in red, while the valence electrons are highlighted in blue. In case of beryllium, the first shell contains 2 core electrons. It acts as shield 1, and as a result, it leads to less shielding as there is only one shell containing core electrons, and this leads to more attraction between the positively charged protons present in the nucleus of beryllium atom and the valence electrons. So in case of beryllium, there are only 4 protons present in the nucleus. In case of magnesium, the first shell contains 2 core electrons acting as shield 1. The second shell contains 8 core electrons acting as shield 2. And this results in moderate shielding as the number of shells are 2 containing core electrons. And this leads to moderate attraction between the 12 protons present in the nucleus of magnesium atom and the valence electrons. In case of calcium, the first shell contains 2 core electrons acting as shield 1. The second shell contains 8 core electrons acting as shield 2. And the third shell containing 8 electrons act as shield 3. Now this results in high shielding as the total number of shells containing the core electrons are 3, and this leads to less attraction between the 20 protons in the nucleus of the calcium atom and the 2 valence electrons present in the outermost shell. So what is ZF? Now ZF is the abbreviation for effective nuclear charge and is defined as the electrostatic force of attraction between the positively charged protons present in the nucleus and the valence electrons present in the outermost shell. Now finally, to summarize, the shielding effect and effective nuclear charge in group 2 elements. As the number of energy levels or shells increases in group 2 elements, there is a corresponding increase in shielding, and as a result, this reduces the effective nuclear charge, and the end result is the electrostatic force of attraction between the protons and the valence electrons are reduced. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.